In this video, we shall be deriving the expectation and variance for the uniform distribution. For more on this topic, you need to subscribe to this channel. The first thing to do is to find the expectation. The expectation of x. The expectation of x is denoted as this to be equal to the integral from a to b x multiplied by f of x dx. So this is what we get if you want to find the expectation for a continuous distribution. For the uniform distribution, we have the integral from a to b x multiplied by f of x is the uniform distribution, which is 1 all over b minus a dx. Of course, we can factor this out to give us 1 all over b minus a integral from a raised to the power of b, then x dx. This is still our expected value of x. If we come over to this side, the next thing to do is to integrate x. So we have as our expected value of x to be equal to 1 all over b minus a. If we integrate x, we get x squared all over 2. We now put the range, and this is equal to, anywhere we see x we put b, anywhere we see x again we put a. So we have 1 all over b minus a. In resolving this, we have b squared all over 2 minus a squared all over 2. So our expected value of x is equal to 1 all over b minus a into b minus a, b squared minus a squared all over 2. This, if we multiply it with this, we get b squared minus a squared all over 2b minus a, which is our expected value of x. And if we expand this, if we expand b squared minus a squared, what we'll get is b minus a and b plus a all over 2b minus a. Of course, this will cancel this, so we can write our expected value of x to be equal to a plus b, which is the same thing as b plus a, all over 2. So this is our expected value of x. For more on this topic, you need to subscribe to this channel.